Okay, the calcium is going to bind to the muscle fibers. What do I have calcium? Blue? I got all these. Oh my gosh, this is like a total chaotic mess. Hopefully if I get color on myself, it's the blue that matches. Wrong blue. Oh well. Calcium is going to bind to the actin myosin. And that's going to cause it to change shape. The change of the shape allows the actin and the myosin now to be bound together. Cleaned up at the Pack the Place. I won the raffle on the Spirit Prize.
Oh, remember Kenzie was like, can I have that one? And you were like, no, I like this.
I've got like so much Salmonok swag now. I like this one.
Yeah, I was looking at those. Yeah.
First thing I want. The actin is bound to the myosin. Now what is the myosin going to do?
What's the myosin going to do?
What's the myosin going to do?
It's going to pull it.
It's going to pull it. Where's my red? Red, where'd you go, Red? Oh, there you are. And what's that going to do to the length of the sarcomere?
Short.
Okay, so this is before, this is after. So does my myosin change length?
No.
No, good. Okay, is there less actin?
No, they just overlap.
Yeah, see how there's the gap there? That gap closes. Alright, so now the actin is fully contracted. Okay? And this is bound. Okay? So, when gosh, I don't know what to do here. Panic. Get flustered. Just panic.
Hey,
Tell
Kylie.
people, just panic. Your brain responds well to panic. When you're panicking, your neurotransmitters are just firing.
Freaking out.
Yeah. So when you're panicking, your brain, your body is sending out signals to use more neurotransmitters, use more brain signals to open up as many avenues to find a solution to your panic as possible. It reduces your lifespan because all that is work. Okay, so all right, so I'm here, contracted right now. However, my muscle doesn't stay contracted forever, right?
Right? No.
So anybody want to guess what's going to happen when I do this?
They're going to...
So what's going to happen?
The gap is going to open.
Right, the gap is going to open. But is the gap going to open magically? Remember, our body, everything in our bodies happens because of chemical reactions. Okay? Everything that happens in our body, whether it's your brain, okay, your muscles, your nerves, whatever, is a chemical reaction. Okay? Sometimes I always feel bad like telling the kids that. It's like, you're nothing but a series of chemical reactions. When you fall in love with your kitten, it's chemical reactions. Okay, like if you change the chemicals in your brain, you won't have that love for your cat anymore. It's weird. It's kind of sad, but it doesn't change the specialness of the moment. It doesn't change the specialness of it. It's just chemicals.
Just like butterflies in your stomach, isn't that like a rush of adrenaline or something?
You know what I like to do in this class? Oh, I want to put up my question log on the
Can I
Chromebook.
write that on there?
Yeah, because there's so many questions that come up in this class, and I like to answer them. And I forget a lot, so I'm going to have a question log. Also with the music request log in there too, right? Butterflies, what are they? Because a lot of times, I don't know, and I want to learn this stuff.
Yeah.
So butterflies in the stomach. Yeah, it's not going to magically move. Your body, your cells don't do things unless they're told to do something. Or they get a signal. So what could happen that's going to cause this to go back to this? So think about what caused it to get there in the first place, and then maybe work in reverse. Luke Enders, you've been quiet. I want you to dominate this.
The calcium would detach and go away, and then there wouldn't be a need to make more, and then waste more, so it would just stop.
You want to wheel that cart toward Luke?
Oh yeah.
Yeah. Okay, that's a good start. He said said the calcium releases. And when the calcium releases, okay, what's going to happen to the shape of the actin here? Is it going to be stuck anymore?
Nope.
No.
It's gonna de-stick.
One more step to that is, how is the calcium going to release? Just keep working in reverse. Caitlin, you want this cartwheel over your way? It's a long wheel to get over there.
Is it the ACH and the receptors? They're going to.
So what caused the calcium floodgates to open in the first place?
Action.
So we had an action potential. All right.
It's going to.
Let's go. And then something happened which caused the floodgates to open.
The release of the ACH
Yep.
in a connection to the receptor.
So this opened when this connected.
Yeah.
So what might stop the flood of calcium?
We need to disconnect.
Yes! So we're going to disconnect.
Yay.
Someone wheel that card over there. Do you like sitting over there?
Yeah, I do.
You can. You can move over here if you want. You know.
Okay.
So I want to let you know you didn't have to sit on that side. You know, I feel like I mean, something like that. It's cool. You get some space, privacy. It's probably nice because all your other classes are probably really packed together. It's class rules, right?
I have a question.
Anyway, let me clarify what you just said. The ACH is going to no longer be attached to our receptors. When the ACH is no longer attached to our receptors, what's going to happen to the floodgates? Close. No more calcium. And this, I always like to just spew this thought, because sometimes the more you learn about science, or the more you learn about anatomy and physiology, the less you really understand. The more confused you really are. Think about this. I want to move my finger. What do I do? I want to move it and then get it back to normal. I do this, right? All that happened to do this. I mean, think about that. All this is taking place right now in my finger.
And it happens so fast.
It's unfathomable.
It's kind of weird.
Okay, that's why I said the more you understand sometime, the more amazed you are. You almost have to think it's magic. Like, how could this not be magic? How could all this just happen? And it happens without fail. It's not like once in a while this fails to happen, right? Where you go like this and it just doesn't. No, it does it every time. So it's just, this is why I love anatomy so much, is, my goodness, okay, to do research on this stuff, to figure out why this happens. That's why a lot of people also kind of like to interject like the supernatural into the natural. Well, yeah, this is all a natural process, and it's happened over long periods of time to perfect it. It almost kind of seems like there's some magic force also helping it along the way. So it's kind of a good way to balance the two ideas of natural acts and then just how awesome the body is altogether. But anyway, that is a neuromuscular junction and contraction.
So when like calcium closes and the muscle relaxes, the myosin and active, like the myosin is no longer attached, or no longer going active.
Yep, so let me do like a real quick summary. Action potential, brain sends out a signal to the axon. Okay, when the signal gets to the terminal, releases acetylcholine, neurotransmitter. This is called the synaptic cleft, but we don't need to know that. And it attaches to the receptor of the muscle fiber. That muscle fiber, when it's attached, is going to open up calcium. Calcium is going to be released into the sarcomere. Calcium will bind to the actin-myosin complex, causing it to actin and myosin to come together. So the actin can be pulled by the myosin and contract. When the body is ready to stop contracting, okay, actually what will happen, and one of the things that we'll learn about is drugs and how the drugs work. The acetylcholine is removed from the receptor. There's an enzyme that comes and breaks it down, okay, and then no acetylcholine, no more calcium. Calcium eventually stop binding. It only has a limited time that it can stay on, and then it will go back to the relaxed position. muscle relaxers,
Oh.
painkillers. What they do, how they work, is in different forms of neuromuscular junctions, they stop these neurotransmitters. So you've got a pain signal. Pain signal, if you, say something's throbbing, okay? There's a lot of neuromuscular junctions along the way that require this. So what a lot of painkillers do is they block these neurotransmitters, and that kind of stops the signal. Okay, that stops the signal to the brain and to the muscle or wherever, say pain. We're going to learn about a disorder, a pretty cool video, which we'll probably watch Monday or Tuesday. Actually, probably Tuesday, because I want you guys to add something to your models for this. It's called dystonia, and I think I mentioned it before. It's where there's a constant signal to the muscle to contract, and you can't stop it. So we're going to see a guy whose muscles are always in this position all the time because they're constantly contracted. And obviously, scientists want to come up with a way to cure that. One of the ways to do that is to interrupt the signal. So we'll see in the video they're trying to interrupt the signal. So really, it's not a muscular disorder, but what kind of disorder? It's a neural disorder. Yeah, the brain signal is constantly being fired to contract. So that's interesting. It's a fascinating stuff. And it's awesome when you see people with these conditions and they're just like living their life, like it's all good. What was the one video we watched where a guy was it the guy with the bones, I think? Oh yeah, the real small guy who was just like, I'm cool. I couldn't imagine doing anything other than this. Then we'll see a guy who's just the opposite. His muscles don't contract, and he wastes away into like nothing. Like his mom just reaches over and just picks him up like this. So we'll do that next week. So with the last few minutes, not a bad idea to maybe take a look at some of the stuff in your daily log. Now, there's some homework questions due Tuesday. 2 things you can do. You can do them on the sheet, or I sent them to you in the daily log. So I sent them to you. So do you guys think you got a handle down on these definitions? Neurotransmitter, action potential, motor neuron. Motor neuron, I didn't use that term a lot, but it's right here. A neuron is what kind of cell? It's a nerve cell. Motor is a specific type of nerve cell. What would a motor neuron be responsible for doing?
Talking.
Movement, motoring. Does every nerve result in movement?
No.
No, about all the nerves in your brain, not necessarily causing movement, but sending signals. Synapse. Synapse. What is a synapse? It's a good word to know. That's one reason I added it in here. What is a synapse? What's in your book? I want to make sure you can find it without me just telling you. Do you guys, did anybody click on this link?
No.
Oh, there's also 2 short YouTube videos that go over this process.
Alright, sweet. Sweet things.
The only thing about the YouTube videos is you just kind of have to block some of the extra terms out, you know? Because it goes into more detail than I need. This is handy. It's a lot of nice hyperlinks. So let's say you're going over it and, a neurotransmitter. Click on that. It'll be a nice thing about neurotransmitters. So I found this page. It took me a long time to find a page that was detailed enough without being like college level. So, synapse, come on, give it to me. Oh well. Synapse is the joint between, synapse is like the joint. It's basically a neuromuscular junction. But a synapse can be nerve and nerve too. It doesn't have to be between a muscle. So it's the junction, really. It's the junction. Okay. All right, questions for me? Oh, my video still recording?
Oh, I forgot about that.
Right. I'll post this on